Okay guys, we're back to doing our review, even though we're not doing our test on this chapter. I still make sure you guys see this. I know some of you guys need this for college. So let's make sure. So this one says complete the identity. So as I look at this, I think the first step would be to translate this into sine. So we're going to do this 1 over sine, that's that identity, times sine x plus cosine x. I'm going to distribute that in. So sine times 1 over sine will give me 1 plus, and then this gives me cosine over sine. I know that tangent is tisk, so that means cosine over sine has to be cotan. So we now can rewrite this as 1 plus cotangent of x. That's as small as I can get that. There's no other ways to simplify. Looking at this one, I have a cotangent, a tangent, and a cosine. You guys can probably multiply this out like it is and then switch it into sine and cosine. I like to switch it into sine and cosine first. So tangent is tisk sine x over cosine x. And cotangent is cosine x over sine x minus cosine. Again, we're going to distribute. You see with the first ones, they're reciprocals of each other. That leaves you just with that one. And then on the second one, we distribute that to it. We have a cosine in the numerator and a cosine in the denominator, so it becomes just minus sine x. Again, that's as far as that one can go. For example, number 3 here, we see that we have to complete this identity as well. My first step was to get a common denominator, so I multiplied the 1 by 1 plus cosine x over 1 plus cosine x. That gives me 1 plus cosine x minus sine squared x all over 1 plus cosine x. We have that Pythagorean identity that I'm going to use. Sine squared x plus cosine squared x equals 1. I'm going to solve that for sine squared, so that would give me sine squared x equals 1 minus cosine squared x. I'm able to substitute that in. So I have 1 plus cosine squared, or cosine x minus, I put in parentheses just for safety to make sure that I don't forget to distribute that negative, 1 minus cosine squared x all over 1 plus cosine x. Okay, we're getting close. So we have 1 minus 1, so those go away. And then I'm just left with, I'm going to write it up here so that way you guys don't run into that little logo. I can't see it on these. So cosine x minus a negative makes it a plus cosine squared x all over that 1 plus cosine x. Hopefully you're starting to see that we have something happening in the numerator, so I can factor out a cosine x. So we end up with 1 plus cosine x over 1 plus cosine x. We have something in common in the numerator and denominator. Those are equivalent to 1, and we're left with just cosine x. Okay, I have to pause so I can readjust my page. Please pause as you need to make sure you're getting this down. The last one on page 1 says rewrite this expression in terms of the given function or functions. So this one's saying that you want to rewrite this in terms of sine and cosine. So I'm going to start by writing this out as 1 over sine x. And we see that cosecant here would also be plus tangent x over sine x. Without switching that tangent squared into anything, I'm able to see that this will be a common denominator, which means that I'm going to arrive at 1 plus tangent squared x all over sine. Tangent squared plus 1 is an identity. That's equivalent to secant. Those are the Pythagorean identities we had before. Over sine x. Helps if I draw that bar. I've been trying to get it in there. Okay, so one's in terms of sine and cosine. So secant is 1 over cosine. So secant squared would be 1 over cosine squared sine x. And that's going to be our final answer on this one. Okay, so the next one we see, we want to find the exact value of the expression. Well, sometimes we see these cosine different and they're numbers that are on our unit circle, but neither 145 or 245, or 5 are on our unit circle. So what we can do is actually perform this operation. So cosine, and then 245 minus 5 is 240. And we see that 240 is on our unit circle. So if you look for cosine, chicken strips, you see that that should be a negative 1/2. And then here you see you have cosine, cosine plus sine, sine. So it said write this expression as a cosine of the angles, blah, blah, blah. So what we want to do is we see that this would be a cosine difference based on the cosine, cosine plus sine, sine. So we're going to have cosine of 155 plus, nope, difference, Jenkins, difference, minus 35. When we subtract that, we get cosine of 120. Once again, you're looking on your unit circle, chicken strips. You see there, it is going to be a negative 1/2. And then again, we end up with cosine, our sine, cosine plus cosine, sine. We look at our identities and we see which one that's going to be. That's going to be a sine plus, so 20 plus 40, which gives me sine of 60. So go to your unit circle, we're going to find our value of sine. So the chicken strip, second one, square root of 3 over 2. Okay, and then the last one we're going to do on this slide is going to be that, okay, so use the information to find the exact value of the expressions. So sine of alpha is 5 over 13 and lies in quadrant 2, and cosine of 15 over 17. Beta lies in quadrant 1. Find the value of sine, and then alpha minus beta. So if you look up that identity, sine alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. Okay. To be able to find this means we're going to have to use triangles. So you see that this one is going to be in this quadrant right here. And that's cosine quadrant 2, quadrant 1. So I'm going to do quadrant 1 first. That's beta here. Then cosine is adjacent over hypotenuse. Adjacent is 15. Hypotenuse is 17. The other triangle is going to be in the second quadrant. Okay, and that's going to be alpha. And it's opposite, 5 over hypotenuse 13. You got to do some Pythagorean Theorem. So to find this, it's going to be the square root of 17 squared minus 15 squared. And that's going to give me 8. And on the other one, we end up with okay, let me peek real quick. I've got to use my cell phone to use as a calculator. You should be doing it with me while I'm doing it. Okay. Okay, and it will be 12. Okay, so here you see that 12 should be negative because it's in the negative x direction. That's the only one that should have that. Okay. Then we go over here and we see that sine of alpha. Well, sine of alpha is what we had originally, 5 over 13, times cosine of beta, again, what we were given in the beginning, 15 over 17, and then minus cosine of alpha. Well, cosine of alpha is going to be negative 12 over 13. And then times sine of beta, 8 over 17. Okay, let me do some multiplying here. 13 times 17 is 221. So for my denominator, 221. And then I'm going to have 5 times 15, 75, plus 12 times 8, 96. So 96 plus 75, 171. Okay, double check my math there, but that seems to be what holds true. Okay, I'm going to clear my slide. Remember on this one, though, that you have to create the triangles. Make sure you notice which quadrants they're in. Okay, so here you see you have tangent 20 plus tangent 10 all over 1 minus tan 20 times tan 10. We need to look back and see. We know it's going to be a tangent identity because tangent's in it. But is it going to be plus or minus? So that we see with this, arrangement is going to be tan plus. So that's 20 plus 10, which gives me tangent of 30. For tan of 30, remember it's tisk. So we have at 30 1/2 over square root of 3 over 2. The same thing as 1/2 times the reciprocal, 2 over the square root of 3. The 2's are equivalent to 1, so you're left with 1 over the square root of 3. We've got to rationalize top and bottom. Gives me the square root of 3 over 3. Okay, again, let me know. Okay, this one says find sine of 2 theta. So we can go use our identity and we see that 2 sine theta times cosine theta is the formula for that. So we can do 2 times sine. So sine is opposite over hypotenuse, so that's 20 over 25 times cosine, 15 over 25. Okay, multiplying these out, we see we get, trying to see if there's anything, so 5 goes into these, that becomes 4. Let me write this in a different color. So 5 goes into 24 times, 5 goes into 25 5 times, 5 goes into 15 3 times, 5 goes into 25 5 times. Okay, so 2 times 4 is 8, 8 times 3 is 24. And the bottom is 5 times 5, that's 25. Okay, the next one up, we have sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So I'm going to start with sine of 2 theta. So this tells us this is lying in quadrant 3. So when I'm over here, I know it's going to be over here. And we know that this is sine. Your hypotenuse is going to be the one that's not negative, but the x value is -5. And then we have to figure out what the missing side length is. This is one of those special right triangles, or Pythagorean triples, I think is what we officially call it. So you have 13 squared minus 5 squared, square rooted, which equals -12. Notice that this also has to be negative because it's going down. You could also know all students take, this is the region where tangent's the one that's positive. So now that we have all of these filled out, we can do sine of 2 theta equals 2 cosine theta sine theta. I think I flipped those, but since it's multiplication, it shouldn't matter. So 2 cosine is adjacent over hypotenuse, so -5 over 13. You guys saw me do that? I flipped it. I'm sorry. Still the same solving, but these just switch places. This 5 and that 12. This part here, since it's sine, this should be the -5. -5, and this part here should be the -12. Okay, so I did have that right. So for sine, it would be that, and cosine would be that -12 over 13. When we multiply these together, you end up with 12 times 5 should be 60 times 2 is 120. 120 over 169. Trying to see if there's anything else I'd be able to take out of that. Right now I feel like that's all that I can. Okay. Our next one up is going to be cosine of 2 theta. There's a couple options for this one. I went with 1 minus sine squared theta. The only reason I went with this one, I dropped a 2 here as well, was because it had sine in it, and sine was what was given. So 1 minus 2 times -5 over 13 squared. That gives me 1 minus 25 minus 2 times 25 over 169, which gives me 169 over 169 minus 50 over 169, which gives me 119 over 169. Okay, and last but not least is tangent. Tangent of 2 theta. Our formula for that was 2 tan theta over 1 minus tan squared theta. So for this one, tangent, it's opposite tisk. So hold on, so opposite over adjacent. Opposite is the negative 5 over 12. So 5 over 12, 2 times 5 over 12 over 1 minus 5 over 12 squared. This gives me 5 over 6. And then the denominator is 1 minus 25 over 144, which is going to be the equivalent of 144 over 144. Okay, 144 minus 25 is 119 over 144. That's the same thing as multiplying by the reciprocal, 5 over 6 times 144 over 119. I know that 5 does not go into 119. I know that 6, let's see if that goes into 144 evenly. It does. 6 goes into 144 24 times. So we have 24 times 5, which is 120 over 119. And that would stay positive because tangent is positive there. Okay, and then the last one on this one is that cosine, or cotangent equals 2. Nope, let's try it again. Cotangent equals sine of 2x over 1 minus cosine of 2x. We got to use those double angles again, so I can rewrite this as sine is 2 sine x cosine x all over 1 minus. And then I'm choosing to do this in terms of sine, so I chose that one as 1 minus 2 sine squared x. Remember with that negative, it's got to go to both of them. So here I have 2 sine x cosine x all over 1 minus 1. That goes away, and then that makes that 2 sine squared x. This is looking pretty good. You see we have 2's in the numerators and denominator. There's a sign in each of them, so I can take one of the signs away from the sine squared and the sign in the numerator. I'm left with cosine x over sine x. We know tangent's tisk, so cosine over sine means this is cotangent x, which is what we were searching for. Verifying that's the same thing we have here. Check, check, win-win. Okay, this is all I'm going to make you guys do for the first half of the review. I'll post the other half tomorrow.